file underneath the hood. You can set policies about that. And then in the presentation layer, when you generate your web page, you're probably going to want to make a decision about whether the user should see a particular button or link in the web page. For instance, you wouldn't show a user the delete account button unless they have permission to delete an account. So in a lot of web applications, it's separate. The developer implements this check in the presentation layer to show the button, and then got a bunch of code somewhere else in the app where they check permission in the business logic. It's the exact same check. So what we're doing is we're encapsulating it in a single function that you call in both places. That way you don't mess up. The code doesn't get out of sync. Obviously, the worst thing you can do is only make the check in the presentation layer and not make it in the business logic. And we see that pretty often. That would allow an attacker to forge the request with the request for the business function in it and just have it succeed. That's one of the OWASP top 10 access control problems. So we're trying to address that here by making it really easy for developers. Let's talk about direct object references. So this is another one of the OWASP top 10 in the access control area. We see a lot of apps that have URLs like this. File equals report123.xls. We call this a direct object reference because it's directly referring to the file on the back end. So it's like the developer's handle to this. Well, attackers love this stuff because they want to inject, do .. injection or null byte injection or path manipulation of some other kind to try to manipulate that path name and access some other file. Well, if you're using the actual handle in the URL, you expose yourself to this. So what we want developers to do is to use an indirect object reference. So we've provided this object called an access reference map that does a sort of a translation. The developer can replace the file name with an indirect object reference with a simple call, get indirect object reference, and then translate it back into the direct object reference when they receive the response back. So now they've completely obfuscated the actual file name, and they don't give the attacker any way to attack this. If the attacker changes this to 0 or 5 or blue or a script or something, it's not going to match anything in the map, and so the attacker is just going to get an error message. In fact, ISAPI detects this as an attack because no one should ever be requesting objects that aren't in the access reference map. So that's one example. Here's another example where people are exposing their database keys. Database key is another kind of direct object reference. And so we can translate those into some kind of indirect object reference, in this case, a random string. So we've got both kinds of indirect of access reference maps here. You can do integers or you can do random strings. There's a few benefits to random strings if you want a little added CSRF protection, but there's no requirement to use either one. Yeah. It actually depends on what you want to do. It's just a data structure. You can use it however you want. The most common use case is per user. So if you log on and the user has access to like a dozen files, then you might make an access reference map for them that just has those dozen files, and then you can use those in the presentation layer to generate your UI. You could create a global one if there was a use case for that. I'm not exactly sure what that would be. I can sort of imagine it, but it's kind of like doing your access control check up front. Right? You do the access control check, figure out what the user is allowed to access, and then you generate this access reference map. And then from then on, you just use that. And that makes your access control check really easy.
It's a whitelist.
Yes, it's a whitelist. Exactly. So you don't have to do an access control check, a complicated one on every request. It's sort of, it's like the simplest way to do this, really. But yeah, this is, Jeremiah had many examples in his talk were based on this flaw. Because it's so prevalent on the net. We don't have this best practice out there that people should not expose their direct object references. In fact, someone I know used to call this exposing your privates. He said, never expose your privates, right? That's what this is all about. OK. Now I want to talk about the error handling and logging and intrusion detection architecture in ISAPI. This is kind of new. Not a lot of web applications have this. Most of the stuff in a SAPI is kind of real best practice, like well understood stuff. We tried to go a little beyond that in a SAPI here. So I'm particularly frustrated by the fact that applications will let you attack them forever. If you're a pen tester, you know this, right? You can beat on an application all day with all kinds of crazy stuff that no legitimate user should ever be sending. And what do you get back from the web application? I didn't understand your input. Could you please try again? We need to detect attacks and stop attackers. When we see them doing stuff that no legitimate user could ever do, we should stop them. So we've got this error handling and intrusion detection architecture built into a SAPI that will help with this. So the first thing we did is we defined something called an enterprise security exception. It's a global class, and then there's a bunch of implementations of that: validation exception, access control exception, authentication exception, encryption exception, and so on. And these take two different messages. One message that's intended for the user, and one message that's intended for the logs. Now this solves a problem that developers have. Nowadays, if they catch an exception in their code, they can log it with a bunch of details, but then maybe that log message gets up on the user screen and gives them details about how to hack the site. So we don't want that. But at the same time, you don't want to dumb down the message so that you have nothing useful in your logs. Right? You need both messages. And the exception handling mechanism is a simple, easy, obvious way for developers to handle that. So all you have to do in your code anywhere is throw a security exception, and you get both log messages, and you can deal with them where it makes sense in your code. So just by using a SAPI, you get a whole ton of really great log and error messages just by default. Yeah?
Is there an ID provided so the user message is tied to the log message? So when the user calls support and says, I got ID number?
Yeah, absolutely. So remember, see this little guy here? That represents the user object. So I said earlier that the user object is available anywhere in the application. Well, the logger uses it too. Right? So the logger will get the currently logged in user identity and make it part of the log message. So you'll see a detailed message, user whoever did this action at this time, and here's the specific message about what went wrong. So all enterprise security exceptions automatically get logged. So because all the security controls in a SAPI use the logger, you get great log messages. Right? You run an application and you can see all the access control failures, all the input validation failures, all the encryption exceptions, everything like that ends up in the log, which is where you need it. I don't know if any of you have looked at any enterprise application logs, but they don't have a lot of security information in them because developers don't know what to log and they don't know how to log it. So you get a lot of that stuff for free here. The other thing that we do with these exceptions is we send them to an intrusion detector. So now the idea here is very simple. We're feeding a stream of events into this intrusion detector and allowing it to figure out if any of those events represent an attack. The implementation that we have now is very naive. All it does is allow you to set thresholds on different types of exceptions. So you might set a policy like, if I get more than 20 input validation exceptions in a 3-second period, maybe someone's attacking me. Then I can take some kind of response. I can log it, I can log the user out, or I can disable their account. So that simple policy would probably stop every single scanner on the market dead, right? Because when you scan a site, you generate a lot of traffic really fast, and it's going to blow up it's going to create a lot of exceptions. So you can stop your application